Good afternoon. I'm Jan Hichu, and I'm busy discussing the use of IESve as a building performance assessment program. And through a series of videos that I've shared with you, we've discussed the protocol of basic assessments, looking at ventilation. We've also looked at daylighting and the use of FluxDL. And the recent video looked at Radiance as a tool to understand the one would say the first person perspective of the lighting quality. So in the previous video we talked a little bit about setting up the viewpoints and then measuring lux levels or the illuminance. And in this video which is the second one in terms of natural daylight, we will look at luminance itself. So we're looking here at the light sources themselves. It is valuable in many ways, but it's not. You don't often use it as much. The most direct way that I've been able to use it is as a means of analysis is to look at glare, which is already a type of analysis that really only happens in selected um, contexts or selected studies. So you're welcome to use it and explore the use of it. Like I've said in the previous video, I think Radiance's big potential lies in the use of or the modeling of luminaires themselves, and then understanding the lighting quality within a building or space. Again, there I would implore that you do follow up by yourselves. I think many of you have got some experience already in luminaire design, and see if you can pick it up. And then there's lots of information available as well. Okay, so if we are going to look at luminance, then where we've stopped in the previous round is we've done an illuminance analysis, which ultimately means that we can get an image such as this, the daylight factor, or we can look at the lux levels within a space. Now we can use a luminance study to look at the light sources themselves. And this is an example, for instance, that I started generating. You can see there's a serious problem. I've got a very black ceiling at the moment, which we've adjusted. And you can use that to also undertake a analysis of the lighting quality or the candela, the luminance, but there's also a way of analyzing the glare in the process. But we will do that. So let's assume we've got this model now, and we would like to now see what the changes are. Now, there's one thing that's I think really good about Radiance is that you can actually model the impact of changes to the reflectivity if you change the color and the materials of a surface. It's not a very simple process. You have to um, to adjust the material quality itself, but which means you can either duplicate materials, like you see here. You can develop additional materials like we've done in the previous videos, duplicate it, then define it as a specific one, which I think is better, so that you rather not adjust a single material all the time, but that you actually start duplicating a white wall and a black wall and a gray wall and so forth, because each of them have some differences. In this model, you can take a shortcut, which is simply identifying the material that is currently being used. So we know it's concrete roof with insulation. If you open up that material, that's the material quality. And in the top, you'll see there's something called the external surface. So that's the surface externally that you can adjust the color, or you can use a predefined material, which you can see there's a color, but there's also a surface roughness to it. So that's actually quite good. So you can say, okay, listen here, the material is typically, if we go down here, it might be a steel surface that we're talking about here. So the roughness is quite low, and then you can say, well, that it would be a very dark surface, for instance. This will certainly have an impact in your suncast analysis and so forth. So you're welcome to explore the use of color in your models. We're looking here specifically at the internal experience or the internal light quality. So we will not use external, we'll use the internal um, tab there at the top. And if you click again, you can use a predefined material, or you can then say, okay, wait a minute, we know that in that model it was black. It's not really reflective of what the ceiling is. It's a white ceiling. This is a brilliant white ceiling, and you'll see immediately the reflectance is 1, which means it's a perfect material, which it will never be. So there's already a problem there. But let's assume that that's in place, and you can simply say okay. I often save it, but you can see the color has changed of that material. So again, I will remind you that if you're really doing a rigorous analysis, you would rather actually want to develop a material. So you want to duplicate a material and then simply assign the material to that building entity. But if you are you'd like to quickly see what the impact would be, you can simply change it in this view and change the color. Um, Again, as per the previous round, where we've run a simulation on the standard illuminance, we would now run one on luminance itself. So again, you can use a standard image. You can also use the daylight probability, and you can run the simulation. I'm going to start the simulation so that we can run it. I'll pause the video and then I'll continue again once we've completed the simulation. So I'll pause it now. Good. Okay, welcome back. We've just completed our simulation. It usually doesn't run too long. You can see I've run a few simulations here, and this is the latest simulation image that we've run. Now, just to compare, this was the previous one with the dark ceiling that we noted was incorrect, but I mean it gives us something to consider. As you see, as I hover over parts of this image, we can measure the candela per square meter here. And you'll see that we'll do a comparison in the end, but you'll see that it's already better. You'll see that there's a glare threshold that's being defined. Now that glare threshold is typically 7 times the average luminance of a space. Now to understand glare, I think do go and read up a bit on that again, but we get 2 forms of glare. One's called disability glare, where it's and glare actually, let's go back one step back and say that glare is actually occurs or experienced when there's a significant difference between light qualities. So the human eye is pretty amazing. We can deal with very high levels of light and very low levels of light. Well, most animals are very good with that. There's animals that are much better than that. But what we're not very good with is dealing with 2 qualities at once. And I think most animals struggle with that. So when you've got a very dark space with a very um, light source with high level of light, or that you've got a continuous discomfort or a reflection taking place. We call the one disability glare. That's what we experience when we drive at night or when you walk around at night and it's dark and there's a light source. Then often you struggle to manage with it because you're either momentarily looking at the light source and you're blind, or you're looking at the darkness but then you're missing the light source. So it's difficult to manage both at once. There's something called discomfort glare, which often is about reflection on surfaces like computer surfaces. We're not going to be able to assess discomfort glare here. Discomfort glare really is a way to understand that glare is a reflection of light, and so one could rather use there a rule of thumb or a design process where you can literally draw the light sources from a space, or you would work from experience there. So we can look at the differences between light. So what they've done is there's a number of indexes for glare that you'll see this program uses, but on a very basic level, what's simply stated here is that it takes the average luminance of a space and says that a glare would be experienced 7 times that luminance, which actually just talks about the fact that your eye will adjust to the average, and it could be up to 7 times you could experience some form of glare, or beyond 7 times that. So you'll simply click on glare, and you can click analyze glare. Keep that threshold 0 because then defines the threshold for you. If you don't, well, then you've got to be sure that you know what that threshold is, and it must be referenced, it must mean something. So I would rather just keep it at 0, and you'll see that the threshold here is defined at 2,900, 192. On the left, it's a little bit lower because it's a bit darker, the space, which now means you can actually start seeing, start checking the glare threshold. And you'll see at the moment, it's not really defining glare per se, saying that there's glare being experienced within the space. And any light sources here, if I click on it, you'll see that the light quality is less than that, than the glare threshold. So you can assume at this point you will not experience glare. The one thing to remember about glare is not experienced universally throughout a space. So you'll actually go and define a new point and go and check whether the glare would be experienced at that point. What you can do as well is you can run a threshold or analysis of the candela that we're experiencing, the luminance, and I think this is just an example to show what the lighting quality difference would be if you change the surfaces. And it's only a ceiling, but you'll see the ceiling on the black ceiling as not really reflecting any light at all, while this ceiling is. So it does perform as a light source in that way, and you'll see that there's the light quality therefore is a little bit higher. The impact isn't as dramatic as you would expect, but again, it's yeah, it nothing changes as dramatic as you always would like to believe. You can do two other analyses here, which I think is more valuable if you are looking at light quality, and that's running the lux levels, because we know that lux levels is something we can measure better if you change the surfaces inside. So that's I think is quite nice, a way of exploring the first person perspective of the light qualities. So just to wrap up again, there's a lot more behind Radiance than simply this, and this course is just, unfortunately, there's a limit to what can be covered in this course. But with in due time, I'll release more videos so we can actually look into the use of luminaires, because I think that's where the use of Radiance really becomes valuable. But certainly, this is a good way to start looking at the lighting experience inside a space. A much more of you have to interpret it a bit more, but it does give us an understanding, and you can actually start changing the surface qualities and see what the implications there is. And simply, you can also change the room geometries, and that should also give you some changes in terms of the lighting quality. So yeah, this concludes the first set of videos on IES. I'll certainly develop more, but you're welcome to contact me should you have any questions or aspects that you find difficult, and we will tackle that and address it accordingly. Good. Well, thank you very much, and you can contact me in the classroom. Cheers.